Hello everyone, I'm Prasad from Structure Guide. Today we are going to discuss about factors affecting durability of concrete. As you know, when you design a structure, we specify the design life. That may be 100 years, that may be 50 years, or maybe 30 years. It's depends. So once you do the design and do the construction, we expect the structure lasts for at least that particular design period without making any trouble to us. If the structure is not that durable or the structural components are not that durable enough, then we are in trouble. So today we are going to discuss about those factors that affect to the durability of concrete. How do you overcome and how do you manage that? All those we are going to discuss today. Because these factors are very important to know as a designer or as contractors. Because we should avoid any impact of these factors. Otherwise, we will be in trouble. Let's start with the curing. Because when you do the construction after pouring the concrete, we do curing. What is curing? The curing, as you all know, is the basic thing. When you do a slab concrete that is not that thick, we pour the water into the concrete surface, or maybe we use chemical or any injection or any curing agent to protect the concrete surface, right? Say this is concrete surface, we pour water or anything, we apply curing agent to protect the concrete surface. Why we need to do the curing? When you have a concrete like this, you have a reinforcement somewhere, right? What happened during the curing? When you have a thick concrete, we have a different factors to be considered in relation to the curing. That is temperature gradient, temperature difference, and the core temperature, rise of the core temperature. I'm not going to discuss all those, but if I briefly tell you, the core temperature difference is different between core and surface. Gradient is this temperature difference per unit length. That's all. This gradient we have to know. We have to maintain at certain level. Now let's come to a thin slab. It will be easy for us to understand. We have a reinforcement here. In thin slabs, mostly we do water. Water curing. We apply water to protect the concrete. What happens if we don't do the curing properly? We have a reinforcement like this. This is a concrete surface. Now we know what is the water cement ratio. Water cement ratio. The ratio between water and cement. This is very important. This is connected with the strength. Okay. Now how do we make the concrete? Combination of the water and cement make the concrete, right? This combination, reaction between concrete and cement, create the concrete together with the other binders and all that. Also they are sand and aggregate, but this reaction made the cement. So in a mixed design, we specify certain cement content and certain water content, right? So adequate water will be added in the mixed design to make this mixture. And what if we don't do curing? So this water in this zone will be evaporated, right? Water will evaporate. So there won't be adequate water to react with cement. So what happened? The reaction would happen partially. So let's say you expect grade 25 concrete, but you get 20. Lower grade will be there because you don't have adequate water there to react. So that's one thing. Okay, the first thing. Second one, if this water will be evaporated, the concrete will dry fast. Okay, then these cracks will be accumulated. There may be sinkage crack and also dry sinkage cracks also appear. So due to the fast drying, the cracks will be appear like this. Right, now let's see how these two factors affect in the durability of the concrete. Now, when you talk about the durability, we want to make the good concrete, and also we need to protect the reinforcement. In the reinforced concrete structure, the reinforcement is very important because they are the element that carry mostly the tension, but some cases like columns, which carry the compression as well. Therefore, reinforcement is very important. Especially tension areas, the reinforcement the one carry the stress, not the concrete. So we need to have a reinforcement definitely, right? That we have to keep in mind. Okay, now if the cracks are there, what happened? Now you know in the atmosphere we have a oxygen. We have oxygen and H2O, water, moisture. If we have oxygen and the water or the moisture, this can harm the reinforcement. Corrosion will process if we have these two components. If cracks are forming, there is a possibility of this oxygen and moisture to reach there. Other than that, I will discuss the other factors later. Later, what are the? Let us now. We are going to discuss about the chemical attack later. But if I mention here, now if we have a chloride environment here, so this chloride will attack or reach very easily to here, and carbonation is there, that affect to the durability. So carbonation front will reach there very easily if we have a cracks, right? That's the first issue we are having. Again, now if you look at the second issue, that reduction in the grade. If you reduce the grade, strength will be low, weak concrete is there. So there is a high possibility of penetrating the chemicals and all that to the reinforcement. Permeability will be an issue. If with the high permeability with the low grade, penetration of the chemical etc. into the concrete will be high. Therefore, the corrosion will be happening. Therefore, we have to make sure proper curing during the construction. This is one of the most important factor beyond the control of the design. We have to control this during the construction process. If you are not doing the curing properly, these chemicals will penetrate into the concrete and it will reach to the reinforcement and corrosion will happen. Second thing we are going to discuss about the defects. Construction is the first factor, the curing. Second factor is the construction defects. That is, so this is now I'm going to take two factors here. One is the cracking of the concrete. Other one is the honeycomb. In a columns we do have a plaster. Generally we do the plaster. Say someone have some cracks has worm that is maybe not within the acceptable limit. Say if your acceptable limit for this case is 0.3 millimeter, if this is like 1 millimeter, you need to repair this, right? Here there's a honeycomb, considerable honeycomb is there, so your reinforcement bar will be like this, right? Your reinforcement, the cracks have penetrated into the reinforcement, and honeycomb also in the zone of the reinforcement. What you do is this contractor won't seal the cracks or didn't repair the honeycomb and do the plastering. Now what happened? Now with the time, the weather will make the issue. When it rain, water can penetrate into this plaster. Through the plaster, plaster is very high permeable. It's very porous material. Through the plaster, water can easily penetrate. Also, oxygen in the dry days, when it get dry, oxygen also can reach. Now you have moisture and oxygen there, right? Then oxygen, water comes with the rain, and the dry days oxygen come to here with natural cause. So you have oxygen and water or moisture there, as I explained previously. Then corrosion happens. Similar thing happen at the honeycomb as well. The oxygen in the atmosphere can easily penetrate into the honeycomb, and also moisture will be collected here. Then this will affect to the reinforcement. Therefore, we have to repair the construction defect. If you don't repair it, you will suffer because of these durability issues. Therefore, curing and construction defect, you have to make sure these two factors I took here for the today's discussion are coming from the construction aspects. So we have to make sure construction is done properly. Okay, there are so many things related to construction, but I am going to highlight these two factors for today's discussion. Right, let's move on to the design side. What we can do in relation to the design when you talk about durability of the structures, or when you talk about the factors affecting durability. So the methods to avoid the durability issues. First only the exposure conditions. Now when we are going to build a structure, we don't get the structures wherever you have a land there, so we have to build it there. So you can't say this is in this ground we have chloride, we can't build a house there. That we can't say. We have to take a necessary precaution and we have to build it. So how do you control this exposure condition? Frankly, you can't control. Okay, there will be chemicals, there will be weathering. So environmental factors I discussed previously as well. So these exposure conditions we can't control, but we have to take a decisions. We have to do the design in a way that these factors won't affect to the durability of concrete. We'll discuss the impact of the chemicals on the concrete durability later, but when you take the chemicals now, for example, sulfate or chloride or seawater, if those are there, so you have to make sure your structure can resist those chemicals. For example, when you select the grade of the concrete, or when you select the cover to the reinforcement, or cement content or cement ratios, those parameters should be fixed in relation to these exposure conditions. We have a bad exposure condition, so we have to select this parameter based on the current context, this cover, all those you have to select based on that. Even for the weathering, if you have a wet environment, so you might go for higher cover because it's always damp. So, but when you have a dry area or structure built in dry area, you might go for lesser cover, but you have to maintain the minimum cover. That's how you think about the exposure condition. So in the guideline, there are methods to select this exposure condition, and based on the exposure condition, you can select the concrete grade, board cement ratio, cover, and design life. All those are interconnected, so that based on that you can go. Right. Next we are going to discuss about this resistant. How do we make it resistant to these chemicals? Now, as I explained previously, I'm going to elaborate little more on that actually. Now, chemical attack. Resistant to the chemical attack. What are the chemicals? Let's say seawater. In seawater, there are a lot of chemicals that is not good for the reinforced concrete structures. Chloride, sulfate are commonly we can see. It's not only in the sea but also in other areas or dam sites. Dams, this chemical and all those are disposed in certain areas. So all those areas there will be chloride, sulfate, and manganese and any other those harmful. Even in the sea, similar material will be there. So these material we can't avoid. But when you are going to build a structure in an area, those materials and chemicals are there. So you have to select the type of material or the concrete in a way that it resists to these chemical attacks. Especially selection of the grade, what's in the temperature, cover to the reinforcement, all those as I mentioned previously has to be done according to specified criteria. So there are criteria in the standard to select grade of the concrete or the cement or concrete based on the resistance that we are going to reach or which are expected. So this is actually connected with the design life as well. So you select the cover, you select the concrete grade, cement content, word cement ratio, all those, and the cement type based on these situations. One other thing that I want to mention here is the alkali silica reaction. That is actually not directly connected to cement, but it is a reaction of the components in the concrete with the aggregate. So those also we have to think about when you select the aggregate and all that. That's also important factor. It could create internal low surface cracks, then it will affect to the durability. Through these cracks, as we discussed previously, it would attack to the reinforcement inside the structure, and also when it cracks, the concrete strength also reduces, then also it also loses strength, so that eventually affect to the structural stability and strength. So now I think It's clear to you how do we tackle the chemical attack and what are the type of chemical attack that would be faced when we build a structure. Now let's move to the concrete grade. Now we have discussed many things about the concrete grade. So this concrete grade actually connect with the cement content, what cement ratio, all those things. In addition to that, I want to mention here type of cement. Now, depending on the requirement that we are going to, requirement of the structure that we are going to build, we can select different type of cement. For example, you can select ordinary porcelain cement. You can select cement with fly ash. You can select cement with GGBs, ground granular blast furnace slag. So those additive materials are there to create different cement combinations. So with that, these combinations and the change in the compositions within the cement, we do have cement types like sulfate resistant cement. So those sulfate resistant cement are made by change in the compositions in the cement. So similarly, there are cement types that can fight for factors that affect the durability. For example, sulfate attack. So those can be managed with the selection of these material or the selection of suitable material. Therefore, the cement type selection, cement grade selection is a very important in when you talk about the durability of concrete. So therefore, we have to do this with much care. As the last point, or last factor, we are going to discuss about the properties of the. Here we are not going to discuss all the properties. So one important property of the concrete is the permeability. As we previously also discussed little about the permeability, when you have a high permeability, water or any material easily can penetrate into the concrete. We have harmful chemicals like sulfate, chloride, or any other in the ground, or environment. So all those material can be penetrate into the reinforcement towards the reinforcement easily if the concrete is very permeable. So through this permeability, chloride can easily get into the reinforcement. So that would create corrosion. Then it will spoil the concrete and do the damage to the concrete. One more thing I want to highlight here is the carbonation. Now you have a concrete surface. Let's say this is the reinforcement. You have a carbon dioxide in the environment. So carbon dioxide can, when you heat it in the surface, carbon dioxide can penetrate into the concrete. Now if you have a cracks, this carbon dioxide easily can penetrate into the concrete as we discussed, same as happened in the chloride and all that, as we explained previously. So if you have a cracks, this chemical easily can go into the reinforcement. Now concrete is an alkaline material. The pH of the concrete is about 12 to 13. Usually 12 to 13. Now what happened with this high pH? Now you have a ferrous here, the oxygen there, ferrous oxide. There is a protective layer around the reinforcement with high pH. What happened when you reach the carbon dioxide there? This carbon dioxide react this particular, it damage it. What happened? Now when the carbon dioxide reach there, it damage this protective layer, then the protection is no more there. So what now happen? Now some cracks are there in the concrete, then oxygen and the moisture will penetrate through those cracks into the reinforcement and then do the corrosion damage. When you damage this protection, the chemicals and all that also easily can penetrate and do the damage. Also, damage in this protection would reduce the alkalinity and increase the acidity of the concrete. So with that also, very positive environment for corrosion will happen created. So that would lead eventually to the corrosion of the reinforcement. Therefore, Uh, the permeability is a very important parameter. In addition to that, I discuss about the carbon dioxide action or the penetration into the concrete can do the damage. So with that, I'm going to end the today discussion. Today we discuss about factors affecting the durability of concrete. So important factors that we need to consider when doing the construction and doing the designs were discussed. Curing, construction defect, exposure conditions, chemical attacks, concrete grade, permeability, all those were discussed today. Those are the key factors actually that we need to consider. And also there are more factors that that are connected with the durability of the structure, but today we limited our discussion to this. So you might refer to some other documents as well. You need to learn more and more on this about the durability of the concrete. And also I suggest it's better study more and more because it's very important topic when you define the concrete and do the designs. Thank you very much for watching our videos. Let's meet again from another video. Thank you very much.